Good afternoon. My name is Ravi Babu, Assistant Professor in Institute of Aeronautical Engineering. Today, we are going to seeing in the Model 2, that is System Response. In the System Response, we are going to analyzing here discrete system analysis by using, in previous sections, we see the jet transform methods. After that one, we go for the another method is jet transform. In case of the jet transform, we see the four methods. In four methods, we find out the jet transform method, reduced method, okay, differential equation method, power method. We have completed that one. Now we are going to for another analyzing method for your analysis for discrete time systems analysis is differential equations. We are going to here seeing the differential equations solutions by jet transform method. Now, generally for finding any system behavior, we are having the input-output parameters. For analyzing that input-output parameters, in case of here discrete time control, linear time invariant systems, that is LTI systems, we have to analyzing that one with behavior of input and output. So, sigma I equal to 0 to n, y of k minus 1 I it is the output function. Okay, a is the magnitude function equal to the input of the function where m less than n variables. So this is the discrete time linear time invariant system representation. Similarly, I am going for the sampling for that one, that is in some particular period. If it is backward period or forward period, I am taking some intervals, that is I am taking as for forward path, that is k plus 1. So this output is also given to equivalence of this input function also. This is in case of the discrete time linear time invariant systems. Now the general procedure to solve the differential equation. Generally, for finding the differential equation, first of all, you have to apply the jet transform on both sides of the differential equation. For given discrete time systems, you have to first of all apply the jet transform on both sides of the LHS side and RHS side of the equations. After that one, if you know the input u of k, find u of z for the expression of y of z. After that one, for finding the expression of y of z from the u of z, so we are going for the z transform, that is y of z, to get the solution of differential equation y of k. This is the general procedure steps for finding the differential equation. And we have to make it is the note that when we are going to finding the differential equations, we are going to taking the one of the property is time shifting property. That is, in this case, the time shifting property of jet transform is very useful. Where it has, we know that from the time shifting property, that is, if in the first equation, that is the term of the x of k is going to be delay with of n, that is nothing but jet transform of x of k minus n, delay with n interval times. For this one, the jet transform is nothing but z inverse of x of j, whereas the time interval is going to forward path of the forward term intervals, that is z of x of k n plus 1 is nothing but initial values of z of n into x of z, and where the time interval starting from the 0 to 1 no, that is k equals 0 to 1 x of k into z power of minus k. So this is the shifting property. We know that one already in previous classes, in that is in jet transform theorems we have to learn this one. That's why once again I am recalling this one. It is very important for finding the differential equation properties, for analyzing the discrete time systems for differential equation formations. So once again I am here recalling the functions as, that is, if x of k is unit delay of negative 1 unit delay, that is x of k minus 1. For this one, z transform is z power of minus 1 into x of z. Whereas if you take similarly for with two intervals, that is x of k in minus 1, that is nothing but it is coming to z power of minus 2 into x of z. Similarly, I am going to for shifting this one into with positive interval section side, that is x of k n plus 1. That is x of k n plus 1 nothing but that is the initial position and 0 position is coming. 0 position is coming. Z into x of z minus z into x of 0. After that one, if you go for the initial positions, okay, sorry, it is z into x plus k into x plus 2. X plus 2, that is nothing but after two intervals. After two intervals, it is coming to as, the power is coming to as z into x square x of z minus initial position minus at 0 position the higher power minus at higher position of minus 1 position. It is coming to as z of x1. These are the shifting properties of the finding the differential equations problems where to analyzing the discrete time analog signals. Now I am going to explain one of the problem for differential equations. Okay, so see the problem here, that is solve the differential equation x of k plus phi x of k minus 1. That is here phi x of k minus 1 is nothing but here it is coming to unit delay. Okay, unit delay k minus 1 delay plus 6 into x of k plus 1 equal to u of k. It is coming like this, where u of k is the unit function, that is step function. For this u of k step functions, if applying the k limits as, that is if k equal 0, greater than 0 nothing but it is coming to as 1, if k equal less than nothing but 0. Already we know the basic function of the step functions. So here by applying the step functions, you have to apply the step functions above differential equation. We find the z transform of this one. For that one, first of all, I am going to taking here given function is x of k plus 5 into x of k minus 1 plus b into x of 6 into x of k minus 2 equal to u of k. Okay, so I am taking first step is, this is your step now, first one. What is that one? First apply z transform on both sides of the differential equation. Both sides of the differential equation. This is the first step. Now I am going to for applying the z transform on both sides. So k is coming to as z, x of z plus it is, see this one, 5 into x of k minus 1, that is nothing but unit delay of negative unit delay, that is x of k minus 1. So what is that for that one? See, x of k minus 1, this one. So what happened? Z power of minus 1 into x of z. Z power of minus 1 into x of z. So take this one. So similarly, 5 into constant term 5 into for this one z power minus 1 into x of z. Next plus here two terms will be there. Two time intervals delay. Time intervals negative delay. That is 6 into z power of minus 2 into same function. Okay, same function x of z equal to u of z. So you have to remember previous problems, very important formulas. Then only you have to solve the problems. Okay, so if you take in this one function, if you take common x of z, 1 plus 5 z power minus 1 plus 6 into z power minus 2 into x of z equal to, okay, x of z equal to, for this one here, this is coming to as z by z minus 1. z by z minus 1. After that one, see this one. Here, if you take z is common now here, so it is coming to as, if you take z power minus 2 is common, so what happened? Z square plus 5z plus 6. Okay, z power minus 2 is I am taking the common. For this one, z power minus 2, if I am taking to other side, it is coming to as z cube by z minus 1. Z cube by z minus 1. Now, similarly, from this one, it is x of z equal to z cube by z minus 1 into this term. Z square plus 5z plus 6. Z square 5z plus 6. After that one, we have to find the z transform for this one. That is, in case of the fast fraction method. All of you know it. When you are finding the fast fraction method, z transform, you know the LHS side of the term, LHS side of the term is in the form of x of z by z. It is in the form of x of z by z. X of z by z. It is the form of. But here x of z is only there. That's why here cube term is no z cube. I am taking this one is z square. One z is coming to denominator of x of z. X of z. So it is coming to the standard form of. It is coming to the standard form of for finding the z transform in case of the Fourier fraction method. Fourier fraction method. Yesterday, last class I explained, no, that's one. So x of z equal to z square by z minus 1 plus z plus 2 plus z plus 3. This is equal to a by z minus 1 plus b by z plus 2 plus c by z plus 3. C by z plus 3. So what happened? If you want to a value, first write the main function of that one, that is z square by, and I am writing here, I want to a. So first I write down total function z minus 1, z plus 2, z plus 3 into what is the a value, denominator value, z minus 1. Z minus 1. Where z minus 1 equal to 0. Z equal to 1. Z minus 1 equal to 0. Z equal to 1. So, if you cancel this one, substitute the z value equal to 1. 1 by 1 plus 2, 1 plus 3. It is coming to as 1 by 3 into 4. That equal to 1 by 12. 1 by 12. We got the a value is 1 by 12 now. This is a process. Already I have explained this one. It is a process for finding the a value. Similarly, go for the b value. What is the b value? First write the total function. B equal to z square by z minus 1, z plus 2, z plus 3 into the b value, denominator value is z plus 2. Where z plus 2 equal to 0, z equal to minus 2. Z equal to minus 2. Substitute here. First of all, this z plus 2 and this z plus 2 is cancelled. Okay, z equal to minus 2. That is minus 2 whole square. That is nothing but 4 by z equal to minus 2. So it is coming to minus 3 into 1. That equal to minus 4 by 3. So we got the minus 4 by 3 value. Minus 4 by 3 value. Now I am going to for c value. Coming for the c value, c equal to the total function z square by z minus 1, z plus 2, z plus 3 into what is the c value, denominator value here? Fourier fraction expression means equation 1, that is z plus 3. Z plus 3, where z equal to minus 3. So cancel this one. This one is cancelled, and z equal to minus 3 now. So that is 9 is coming upside, and denominator side, numerator side is 9, denominator side is minus 4 into minus 1. That equal to 9 by 4. 9 by 4 we got it. C value. So we got the C value here. So what happened? X of z equal to 1 by 12 into, from this equation, x of z equal to, x of z by z equal to a by z minus 1, no, a value is 1 by 12, z minus 1 minus 4 by 3, z plus 2 plus 9 by 4, z plus 3, After that one, here z will be there. So I am again taking to this one into its in this side, arch side. So what happened? X of z equal to 1 by 12 constant term. Here this z is coming to numerator value, no? This is coming to numerator value, z by z minus 1 minus 4 by 3, z by z plus 2 minus plus 9 by 4, z by z plus 3. So apply here p of z alpha. That is, if you get here, x of z is in terms of the x of k. So we know 1 by 12 into z by z minus 1, what is the unit transform? That is minus 1 whole power of k. Okay, but it is step function. For step function, it is coming to as 1. That's why here I am into 1. Minus 4 by 3. It is above the 1 value. That's why we are submitting here minus 2 whole power of k, and similarly for this one minus 3 whole power of k. This is the distributed time system for finding this differential equation. For this differential equation, of this one, this time system output. Okay, so in this way we have to solve the example for solving the differential equation. Now I am going to for another example. See here, that is, here the given is x of k plus 2 equal minus 1.3x of k plus 1 plus 0.4 x of k equal to 0. So with this one, x of 0 equal to 1, x of k1 equal to 1 they given. Now again same process. First of all, write down the given function x of k plus 2 minus 1 by 0.3 x of k plus 1 plus 0.4 into x of k. Taking the z transform on both sides. So it is k plus 2. That is nothing but z square x of z minus z square x of 0 minus z square, so z of x of 1 up to here. This is the equivalent of this one. Next 1 by 3 or minus 1.3 z into, for this one, z into x of z plus, minus 2 into z into x of 0. This is one term. The power is only one term will be there. That's why we are coming. Okay, plus 4 into x of z. Okay, the middle function is power is equal to only 1. That's why it is coming as similar. Already I have explained these formulas here. This is the first term formula. This is the second term formula. Okay, z into x of z minus x of 0. Z into x of z minus z into x of z minus z into x of 0. Okay, that is shifting theorem property. You are applying here. Okay, now after that one, take here x of z is common for total equation. That is, in this one x of z is there. Here 1.3 x of z is there. 0.4 x of z will be there. That's why z square 1.3 z plus 0.4 x of z minus z square x of 0, okay, minus z x of 1 plus 1.3 z x of 0. Okay, so here they given already x of 0 equal to 1. Substitute here x of 0 equal to 1. Here 1 is coming. Here it is 1 coming, and x of 1 it is coming to 1. That's why they written z square only z plus here 1.3 into z into x of 0. No, x of 0 nothing but 1. No, x of 0 equal to 1. That's why 1.3 into z. 1.3 into z. Apply in this above equation. You have to apply the conditions in problem conditions. These conditions you have to apply here, where in our equation. In our equation. For applying these conditions, we are getting this equation. Okay. Now, again same process. We are taking the common as z square minus 1.3 z plus 0.4 into x of z equal to, take this one into in this side, RH side, that is z square minus 1.3 into 1.3 minus 1 nothing but 0.3. 0.3 z. After that one here, I am taking here x of z equal to, this right hand side part, left hand side part is coming to diameter side. Okay, z square minus 1.3 z plus 0.4. In above numerator side, I am taking the z common, that is z into z minus 0.3. Okay, after why I am taking this expression? Why? Because for this expression solution, we are going for partial fraction method. In case of the partial fraction method, the LHS side, okay, the LHS side will be in the form of x of z by z formation. X of z by z formation. This formation. It is in the form of this formation. That's why I am going for this mathematical equation for this one. I am doing the sum of these mathematical applications, simplifications. Here x of z is common taking I am that one. Here numerator part z is common taking I am that one. Okay. After that one, if you take this one into x of z into in this side, that is x of z by z. So what happened? The function is coming as x of z by z equal to z minus 0.3 by z minus, for this one I am taking the LCM. Okay, values, that is nothing but z minus 0.8 into z minus 0.3, sorry 0.5, 0.5 we are getting, 0.5 we are getting. So we are taking the partial fraction of this one, so it is coming to as a by z minus 0.8 plus b by z minus 0.5, b by z minus 0.5. For finding the a, coming for the next one is for finding the a. So what is the, how can you find the a? A equal to what is the total function? (0.8) into z minus 0.5, where the value of a, numerator value is z minus 0.5, where z equal to 0.8. Okay, so this one cancel. Apply z equal to 0.8. So how much value? That is 0.5 by 0.3. We are getting as 5 by 3. You got the 5 by 3. Okay. Similarly, go for the b value. Similar method. We got the values. A value is 5 by 3. B value is 2 by 3. Substitute these values into area. What I have to get? X of z by z equal to 5 by 3 into z minus 0.2 minus 2 by 3 into z minus 0.5. Okay. Apply here universal z transform. Okay. So what? Sorry. Apply z transform. For this one, it is coming as x of z equal to, take this one z into other side. 5 by 3 into z by z minus 0.3 minus 2 by 3 into z by z minus 0.3. After this one, apply here universal Laplace transform. That is x of z is coming to x of k. X of z is coming to x of k. So 5 by 3 into 0.8 whole power of k minus 2 by 3 into 0.5 whole power of k. You know the formula for this one. Already last class has explained, no? You know Z transformation. So this is the way we are going to solving the differential equation. One more method. Now I am going to one more problem. That is, here the given is y of n minus 1 plus y of n plus 1 equal to 1 and y of output equal to by Z transform method. Y of 0 equal to 0. Okay. So first of all, it is given equation. For this given equation, I am taking the Z transform on both sides. So Z transform of y of n minus 1 equal to plus minus Z transform of y of n equal to Z transform of 1. if you take this one Z transform for this one, this function, it is the time interval between delay of the 1 unit time. Delay of the 1 unit time. See the formula. This is the formula for delay of the 1 unit time. This one. Okay. So Z into Y of Z minus initial value. Initial value minus Y of Z equal to Z transfer Z of Z minus 1. Z of Z minus 1. So from this one, that is x z plus 1 into Y of Z equal to Z by Z minus 1 we are getting. For solving this one, reduce to. This is one I am going to be reducing this one in the form. After that one, I am applying that one. Z Y of Z equal to Z by Z minus 1 into this part is coming to as denominator value. This part is coming to as denominator value. So we got this one. Y of Z equal this one. Again same method. By applying the partial fractions, we are getting the values here. But for this one, partial fraction is A value is B value is 1 by 2. Okay, A by Z minus 1, A by Z plus 1. A value is 1 by 2, B value is 1 by 2. So we got this value, answer. After that one, we have to apply a inverse Z transform. So Y of Z is coming to Y of n 1 by 2, 1 minus 1. For this is in step no 1 minus 1 whole power of n. Minus 1 whole power of n. This is one of the example for finding the inverse Z transform. Now I am going for one more problem. That is Y of n minus 2 plus Y of n equal to 1 and the output function y0 y1 equals 0. Okay, and Y of n minus 2 and Y of n minus 1 equal to, I am taking the first one. For this one I am taking the Z transform. Okay, I am taking the Z transform. It is the function of with delay of 2 intervals. That's why here 2 intervals. That's why here coming as power x square into Y of Z minus y0 minus okay y1 of Z plus Y of Z equal to for this one Y of Z equal to Z by Z minus 1. Z by Z minus 1. After that one, taking the Y of Z is common, that is we are getting Z square plus 1 into Z by Z minus 1. So this is your final answer. Now for this one I am going to solve same as factor fraction method, that is Y of Z by Z. Okay, 1 by Z minus 1, A by Z minus 1 plus it is Z square plus 1 term. So the factor fraction method is Bz plus C. Okay, Bz plus C by x square minus 1. After that one, if you take for finding the ABC values, we got it 1 by 2 is common. A equal to 1, B equal to C, 1 by 2, C equal to 1 by 2. Okay, so this is the function I am writing here. For this total function, here Z is in R side, down denominator side. So it is coming to numerator side. This is coming to as 1 by 2, Z by Z minus 1 minus Z square by Z square minus plus 1 plus Z by this one. Taking the inverse Laplace transform, that is Y of k is converted into Y of n. Y of k is converted into Y of n. 1 by 2 into, this is the unit function, that is 1 minus cos n pi by 2 by 2 minus sin n pi by 2. Okay, this is one of the solution for the problem for solving the differential equation problem for analyzing the discrete time systems. Okay, I am going for the next one. Similar way, same procedure, same problems, taking the conditions is very important. You have to remember first of all here one is this factor fraction problem here and the final solution of this one, inverse transform formulas. These two formulas if you know, you can solve this total problem. Okay, first of all take the function and after that one apply Z transform. After that one apply the partial fraction method problem. After that one apply the inverse Z transform. Then we get the solution. Okay, take this problem. Y of n minus 2 plus 6 into Y of n minus 1 plus 9y in this way, no? So first equation one, same equation I am taking. After that one, for this equation one applying the Z transform. Okay, in Z transform we are taking the formation of this formation Y of Z, this formation Y of Z by this formation. After that one partial fractions, for finding the partial fraction values we are getting the equation, apply a universal transform. This is the procedure. This is the procedure for finding the differential equations. Okay. Thanking you. Tomorrow we will continue the other topic. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.